All right. Of course, as soon as I start a video, I have a cough coming on. Welcome, everyone. This is my 12.3 pre-class video. And I decided at the beginning of this video, I thought it'd be a good idea that, and maybe for the first couple weeks even, I could maybe showcase some things that you may not have realized are features of the course. So I'd like to start off with just a little bit of an administrative thing. And then we'll get into 12.3 and a little bit of framing and stuff like this. And again, this is going to be a relatively short pre-course video here. And so the thing that I wanted to showcase today were the study groups. So we did set up here in D2L a way for you guys to, if you want, to join study groups and just meet other students in Math 234. So when you go ahead and click on this, you go to a folder inside of our D2L course. And then this just kind of talks, why we're doing study groups, what are some good uses or etiquette for the study groups, things you should be thinking about. And then you can click on here to go ahead and sign up for study groups. When I do this, it doesn't do a whole lot because I'm an instructor. But basically, we decided on about 12 people or so per study group. I thought was a relatively good number. But yeah, so this is an option that if you're interested in meeting other people in Math 234, which I think has a lot of value because first of all, maybe when you don't know something, I can give you a very, exact, this is the way that you do it sort of deal. But I think getting another student's perspective really has a lot of value. And then the other thing is that if, none of you get it or whatnot, that really gives you, a good reason, a good case to go to office hours or post on the Piazza or go to the MLC or things like this. And you really feel like, you're not alone and not understanding this, right? There's kind of a group of you and whatnot. So anyway, that's one thought. If you're interested in meeting other people, we have got this all set up and everything. So that's one thing that you can do. All right. From here, let me go ahead and jump in. So this is going to be a little bit more classic of a style of kind of pre-class video, at least how I originally had envisioned these things. I would like to take over here. I guess I have to stop sharing really quick with this because I also have my iPad in here. And so I'd like to take over with my iPad really quick. And I'm probably going to have to jump back at least one more time to my desktop. But I want to do a little bit of framing, right? So first of all, because I didn't do this for 12.1 and 12.2, I made this kind of a syllabus video and everything. You will notice in chapter 12, we have exactly 0 calculus, right? Even though that this is called multivariable calculus. So here we're trying to get you set up, ready to do, really visualize things in 3 dimensions. And later comes the calculus. So starting in chapter 13, and again in chapter 14, and kind of there on out, we'll be doing a lot of calculus. But for the time being, this is basically an entire chapter dedicated to algebra and kind of updating and upgrading our algebra knowledge and how to do these things in 3-dimensional space. And in particular, one of the things that becomes really useful in 3 dimensions, right, are these things vectors. So that's, those were brought up in 12.2. So we now have vectors and we now know how to do a few things with them. In 12.2, we learned how to add vectors. And we also learned how to multiply vectors by a scalar, by a number. And this kind of stretches them out or sometimes flips them or things like this. So we saw that in 12.2. Here in 12.3, we would like to learn how to multiply vectors. And it turns out that multiplying vectors, right, if you just do the kind of the silly thing, right, if I told you, hey, multiply these vectors together for me, I know personally myself, if I hadn't really thought about it, if I just was trying to come up with a definition of how to multiply vectors together, I would just multiply them term by term, kind of like what we did for vector addition. So I would say that this is going to be, if I did 1, 2, 3 times 2, 0, 1, that this would be equal to, and I would just take 1 times 2, 2 times 0, and 3 times 1. And I would say, okay, it's going to be the vector 2, 0, 3. And it turns out that this will not be our definition for how to multiply vectors. And moreover, there's not only one definition for how to multiply vectors. It turns out there's 2 really useful ways to multiply vectors. So this is one of the first instances maybe that you're coming across something where now we are going to have 2 different ways to multiply things. And both have their reasons and kind of why we'd want to do these things. Excuse me. So it turns out, so in 12.3, this is called the dot product. 12.4 is called the cross product. So these would be the two different ways to multiply things. And they satisfy a lot of the properties of multiplication that you would like associativity, distributive properties, things like this, kind of the classic multiplication. That's kind of why we use that notation for them. But in this case, this multiplication, quote unquote, the dot product here in 12.3 really comes from a key geometric question. And that key geometric question is, if you have two vectors, we've started to think about the things that you can do with them, the things that you can ask, right? We can ask what happens if you travel along one and then the other, and that ends up being vector addition, right? Another very kind of classic question is, if you have a couple of vectors, you could ask, well, what is the angle between those vectors, right? And we haven't maybe necessarily, at least not in a math class, maybe if you've done this in physics or something like that, we typically haven't asked that for just straight up vectors. We have asked, though, in a math class, I guess this really depends on what math class you're taking, but somewhere in geometry or trig or pre-calculus, if they call it that, you probably were asked to find an angle of a triangle. And so you'll see in the proof, which I'm sure they'll go over with you, right? When they're coming up with the dot product and all this sort of stuff, why it's the angle between some vectors, or why it's used to solve for an angle between some vectors, right? You will see that you will bring up the triangle and actually try to find the angle of that triangle in order to help you find the angle between those vectors. So that is the key problem here. Just kind of think about things, find the angle between these two vectors. This is what I would like you to be thinking about as you're in class about 12.3. By the end of it, you should be able to solve this problem and hopefully a few others. But this is kind of a very key problem and kind of help develop, why we have the dot product, why the notation is, and why this is the definition for multiplication rather than the thing that we would have maybe initially dreamed up. All right, so that's some kind of good framing, I think, for 12.3. Let me go ahead and take over the screen with my desktop here one last time. And I just want to show you a very useful resource. So I'm just going to do a Google search here. So this is the 3D Calc Plotter. This is by Monroe Community College, Paul Seeberger. So this first one right here, this is a very nice kind of low entry. You don't need a lot in order to really get into this and start visualizing some things in 3 dimensions. And so you can see that this has a very interesting surface here. And you can kind of spin it around and all that sort of stuff. Of course, if you know something like MATLAB or Mathematica or stuff like this, you can do way more complicated things. So this does have some limitations, but again, this runs in a browser and it's very easy to get started with it. I really enjoy this. So let me kind of show you if I wanted to make these vectors here. So I'm just going to go ahead and delete this. And I'm going to go ahead and add to the graph a vector. And I had the vectors 1, 2, 3. So let's do 1, 2, 3. And let's make that one red. Why not? And okay, there it is, my vector. You can spin it around and look at it and all that sort of stuff. Let's go ahead and add another vector here. And so the other vector was 2, 0, 1. 2, 0, 1. And so that one maybe we'll do in blue. There we go. So these are the two vectors here. And again, I want to find the angle between these vectors. So again, this kind of gives us a nice way. I can just spin it around and kind of visualize these two vectors. And as we do more and more complicated things, so for instance, when we get into surfaces or even implicit surfaces or parametric surfaces, things like this, this can actually handle this all fairly well. Let me go ahead and showcase just a fun thing really quick, and then the video will be over. So we'll do a parametric surface. Okay, this is maybe some default one. Let's just take a look. So, okay, so this is relatively boring. This is just going to be like a sphere or something like that. And again, you can kind of zoom out, zoom in, all that sort of stuff. I want to do a fun one. So I think that there's, an example. So I want to do an example of a parametric surface. And you got all these fun ones here. let me go ahead and I want to do, so you got all of these, you may have heard of, you know, some of these names and stuff like this. So like a Klein bottle, this is kind of a classic one. Tauruses, you may have heard of this. A Mobius strip, you may have heard of this. Let's do, I don't know even this name here. Let's see what this even looks like. Ooh. All right. That is a fun surface right there. Let's see what happens. If we zoom out, does it keep on going? No, it's just that big. So, okay, we will get into how to create surfaces and parameterizing surfaces and kind of complicated surfaces. Not really so much as complicated as this, but right later on in this course, you could ask like, what is the surface area of this, right? Surface area is essentially, if I wanted to build this out of paper, how much paper do I need in order to get this? Or, right, if this had maybe some thickness, you could ask about the volume, or maybe the volume that encloses or something like that. So, yeah, this is very interesting surface. Let's do one more and then I could really, Deanies? Haha, that's cool. It's like a shell. Anyway, again, it doesn't even look that complicated, right? So this is the one with the check mark. This is the one that it's showing, right? That doesn't even look that complicated. But anyway, that's all things to come. But I think that this is a really great resource here, and it's got a lot of options and nice things in it and everything. So please consider, if you're ever having a hard time visualizing something, use this. All right, well, I think that's about it. Thank you so much for watching, guys. Again, when you're thinking about the dot product, think about angles between vectors. That's really what it was developed for and all that sort of stuff. That's what you're going to be thinking about in 12.3. Thanks, everyone, and I'll see you out there.